So today is an interesting day because we are going to do numericals. Like numericals are very interesting, right? So on which topic we are going to do numericals? So I am having means I have prepared some numericals for you on the topic electric potential and potential difference, which we have studied from the past two videos, which we are studying from the past two videos. So I am having some questions here which I have made, and now we are going to solve those questions. Okay, so let's start with the first question. So first question is first I will read it and then write it. If there is a charge of 10 coulomb brought from infinity to a point, the work required is 105 joules. Find the voltage. So as we know, our Superman triangle will come to help us. So this is our triangle. So it tells that voltage equals to work by coulomb. See, here also it is there. This helps a lot. So we will write down the values first. So how much charge is there? Q equals to 10 coulomb. Yeah. So Q equals to 10 coulomb. Work equals to 105 joule. So V equals to W by Q. So what is W? 105. And what is Q? It is 10. So the answer simply becomes 10.5. So what 10.5? 10.5 volts. Okay. We have to write it in SI units. Okay. So we have solved the first question till now. Let's go on with the second question. Right? Interesting. Now the harder will come. This was an easier one to make a grip, to know the basics one. Now the harder one will also come. Okay, so I will read. If the potential on 2 points A, B is 250 volts and 117 volts respectively, and work required is 211 joules. Find the charge. Okay, so here two voltages are given there. So I think this is a question of potential difference. So let's take the potential difference between these 2 points, and then we will get the from where to where the energy will flow, electrical energy, and what will be the potential difference. So let's start. So 250 minus 117. Okay. So it is 133. So 133 volts are required to move a charge. No, 133 volts is the answer. If 211 joules energy is required, and for a certain charge. So our healthy triangle comes here for helping us basically. So WV C equals to W by V. See here, C equals to W by V. What is our W? It is 211. Okay, so 211 by 133. So let's find, is it a common factor of anybody? 211 and 133. Okay, so we have to do that by the divisibility test. It is not the common factor of 2, 3, and 4 also it is not there, 5 also it's not there, 6 also not. Let's check with 7 also it's not there, 8 also not, 9 also not. So let's directly divide. Okay, it will be easy for 211 by 133. 1 it will come 133. 11 minus 3 is 8. Then 10 minus 3 is 7. So 1 point and 78 is the remainder. So what will come? I will tell you. Just 1 minute. We are giving pointers, so 10 will increase. 1336 are 798 is coming. Okay. So 5 will work, not 6. It's a big value. So let's put it with 5. 5, 3, 55. So now 665 coming. So let's subtract 665 from it. So approximately, we have to not find the accurate point. Some numbers are recurring also. So here approximately value is coming 1.5 electron. Oh no, not electrons. 1.5 coulombs. Okay. So it's an approx value. Yeah. So this is an approx value. So 1.5 coulombs. Uh, for moving 1.5 coulombs of charge in 211 joules, and if the potential difference is such a big number, then 1.5 coulombs charge will be there. Okay, approx. Otherwise, in 1.5678, something a very big numerical value will be there. So this was the question. So next question. Okay, if work required is unknown, W equals to nothing. Then the number of electrons are 10 raised to 20. E equals to 10 raised to 20. The electric potential between 2 points is 123 and 111 respectively. Find the work in kilojoules. Okay. So the potential difference on two different points is one is 123 and one is 111. So the difference between 123 and 111 is we simply know it's 12. Okay, so 12 volts and 10. What does 10 raised to 20 mean? How much coulomb? Uh, the formula here is C. Like in our triangle helps us V equals to W by Q. So W equals to V into Q. So we don't know Q. They have given it in electrons. So electrons equals to 10 raised to 20. What is the formula? Q equals to N into E. So Q is unknown, N is 10 raised to 20 and E is 1.6 into 10 raised to minus 19 coulomb. This is per. Okay, by this formula, by taking this formula 10 raised to 20 into 1.69, we will receive 4. Means 4. Oh no, let's do it. It's not 4. Let me remember, because we have done the same question in the previous videos. Okay, so in the video, do you remember we have done some numericals by this formula? In that we have remembered that the charge on particular 1 coulomb, how much electrons are there? Do you remember? Yeah. So they are 6.25 into 10 raised to 18. Okay, by that formula we have done this question. So we know 10 raised to 20 electrons are there. So there will be charge of 16 coulombs. Okay, and now we have to multiply this. So W equals to 16 into Q. Uh, yeah, 16 into W. So what is the voltage here? 12. So 160, then comes 176, then comes 192. So work equals to 192 joules. But they will not leave us so easily. They have asked in kilojoules. So simply divide it by 1000. The value comes 0.192 kilojoules. Yeah. So this is our final answer. Okay. Now let's do this another question which I have made for you guys. If the work done was 1 kilojoule, and difference of electric potential was 8 joules. So here the difference is directly given to us. So it was means the electric potential was 8 joules. Okay. Then find the charge. First let's find the charge. Okay. V equals to W by Q. So let's find the Q first. Okay. So 1 kilojoule. First we equals to 1000 joule. We have to convert them all into this is one V, 8V. Okay, so we have to first convert them in all SI units and then only we can solve with them. So 1000 by 8 equals to what? So 8 ones are 8, 20 comes, 2s are then 40, 1 to 5. So 125 coulomb is the charge. So P equals to 125 coulomb. But if they have given that you have to find the number of electrons, then what can we do? Yeah. So P equals to 125 by 1.6 into 10 raised to minus 19. Yeah. So P equals to what? We can directly write it. That means we can write 1.25 into 10 raised to 1. Yeah. So because we are giving a point here, that's why 10 square, not 10 raised to 1, because it will come 100 then, and 100 multiplied by 125. 1.25 equals to 125 by 1.6 into 10 raised to minus 19, which now equals to 1.25 by 1.6, 10 raised to 2, and here 10 raised to 2 minus 10 raised to 19. So what will be the answer? They will get added. So it comes 10 raised to 21. So huge number. Yeah. Yeah. So a huge number has come, means came simply. So 10 raised to 21, because we are adding here, and afterwards we will solve this now. We can cancel out this point, so it comes 12.5 by 16 into 10 raised to uh, 21. Okay. Now to do this, means to simplify it more, we have to cut it off with smaller fractions, like for in point. Okay. So let's do it, or let it be. Okay, so the in fraction form also it is good only, no? If we make it like this, 12.5 by 16 into 10 raised to 21. This is the value. This is a good one. Okay, so let it be. So, uh, Q, not Q, number of electrons. So, let it denoted by small n. So, it is number of electrons is 12.5 by 16 into 10 raised to 21. Okay, so this is the answer. Now let's go with the no, not second, of course, fifth question. If you're liking my numericals, if you're liking all the way I'm teaching or anything, you can like this video and share it to your friends, and you can definitely subscribe to my channel. Okay, so now do the fifth question. So here a diagram is given, not a diagram, directly values are given. Okay, so in the diagram only this is written: V equals to 11035, Q equals to 15C, and then work unknown. So work by the triangles above we know work equals to 11035 into 15, right? So let's solve it. 11035 into 15. 5 5s are 25. 5 3s are 15 plus 2 17. So this is our answer, 165525 joules. And here they are asking it in kilojoules. Okay, so it is 1,65,525 joules, and it in kilojoules is simply divided by 1000. So 165,525 by 1000 cancel. So work done in kilojoules is 165.525 kilojoules. Okay, so this were the numericals, and I want to tell you an important question also. That important question of SI, it is of SI unit. So what is the SI unit of the voltage? Not voltage, electric potential or potential difference. So it is V, volts. But also one more SI unit is there. Can you find it? No, I will tell you. It is 1 minute, not this. It is joules per coulomb. Yeah. So basically, voltage means volt equals to work by joules per coulomb. So this is also the SI unit. This question is often asked in Olympiads. Okay, so this was all for today. You can remember this point and tell to your friends also about this. This comes in Olympiad. So this was all for today. Thank you. If you are liking to our videos regularly, then uh, thank you. And if you're liking, but tell others also to like and take benefit of what I am teaching here. So thank you, and share it to everybody and subscribe to my channel. So thank you.